In this session, we're going to look at querying data using ArcGIS. Up to date, we've mostly concerned ourselves with visualizing data using basic symbology, but there's lots we can actually do with the GIS, such as we can extract values from different layers, as well as utilizing a definition query that will show only a certain set of data from one that contains much more than just a single field. What we're going to do is first download the UK places, postcodes and elevation dataset, which is 17 megabyte download onto your computer. However, we need to store this somewhere where we can find it, so I use C drive GIS files, no spaces in the name. I'm going to make a new folder, UK postcodes, to store my data. So with the blank GIS, the first thing we're going to do is add in some data. So we're going to add in here the UK places, postcode and elevation dataset in total. So we'll just connect to a folder that we just made. Within it, we've got three files. We've got SRTM30 UK, which is the elevation dataset. We've got UK places, which are towns, cities, villages. And we have UK postcodes, which are postcode polygons. And we can see from the different icons what file type these individual layers are. And we're just going to drag these in to our GIS. So, turning on the layers, we can see we've got the points, UK places, we have the postcodes as a polygon, and we also have elevation as the underlying elevation dataset for the UK. I'm just quickly going to check my coordinate system by right clicking on the layers, which is our data frame name here, going to properties and coordinate system. It's inherited British National Grid from our dataset, which is the coordinate system we're going to work in. So now we have our data in our GIS. I'm just very quickly just going to change the look and feel of some of our points, just to make it a little bit easier to follow, but too big. I'll just zoom in. Okay, so our first step is that we're going to take some simple identification by selecting a point. And we can do this in several different ways, but the easiest and quickest way to do it is by using the Identify tool, which is this blue circle with an eye inside it. I'm just going to zoom in to an area, and I'm just going to select a point, so this one here, using the Identify tool. So currently we're identifying from the topmost layer, and the place that I've found there is Knutsford. If I click on it there, it focuses on it quite nicely. And you see that we've got some metadata, which is those attributes that are coming from the attribute table. It's only showing us that single point. It also shows us the location in terms of the coordinate system or projection that you already have defined. Now, what if we want to know more about these points, about where they are and how it goes through in the elevation dataset? We can identify from different settings, so we can change it to visible layers. And then if we click on a point, we'll go all the way through. So we're going UK places, which is Upper Mid-Hope. It's within Sheffield postcode region, and it's currently at 221 meters above sea level. And we click another point, we see another example. So this is Site House, Doncaster 6 meters. And so on. So you can see that using the identify tool, changing the option from which to identify, is actually quite a powerful way of just pulling out data manually that you might want to intersect points with other layers. But what if you want to extract data from all of your layers? If you've got, for example, all of the places, but we want to know the elevation of every single point so that we can maybe do some statistics on it. This is a very slow way. We've got 40,000 features to look at, so we're never ever going to be able to do manually identify each one. So we're going to do an intersect, and particularly we're going to use a tool which is called extract values to points. And this tool allows us to intersect each point with the raster layer of elevation, which is SRTM30_UK. We can access the tool by going to Act Toolbox or by going to the search window. So if we search extract values to points and search, and here is our extract values to points, the first tool available. We'll just click this and bring up our extract values to points. So the input point features is UK places, and we can access this via the drop down. Our input raster is SRTM30, and our output point features will store in a known location on our drive. UK places elevations.shp and save. And then we'll leave these two options blank and just click OK. As we wait for the tool to run, we'll just zoom out a little and just to wait for the new data to appear within the GIS. It may take some time considering on the number of points that you have, and I'm just using the results here just to check to see if there's any issues. You can access the results pane by clicking Geoprocessing and Results, and then you can dock it to the side like I have done in my GIS. The extract values work through each one intersecting the point with a raster cell, and it will produce a new field which will be called raster value that will contain the value of the raster cell within that particular layer. So we can see that we now have UK places elevations. If I right click, open attribute table, on the side here we can see raster value, and raster value is the elevation. So if we just select a point, we've got 100 for this one, Simpson Cross, which is the hamlet. If I use the identify tool, Simpson Cross, 100 meters. So we can see that it's accurately working between our area there. So what if you want to intersect more than one layer? Well, it will create multiple raster value fields, so the name isn't terribly informative. So very quickly we're just going to change the name of this. Now Arc doesn't have an easy way to rename the column, so we're just going to have to create a new field, copy the values over into the new field, and then delete the raster value column. And we do it this way. Just very simply, in the attribute table, click the drop down, add field, we'll give it a name of elevation, short integer, a value of 5, just in case we're going up to 1,000 meters or so. Click OK. We've got a new empty field. I'm going to copy the values from raster value into this field by right clicking on the elevation title, field calculator. It asks us if we want to calculate outside an edit session. Yes, we do. All I'm going to do in the code block at the bottom here is just put raster value. So every row will have the value of the raster value row. Just click OK. may take a short amount of time, and it's done just one here. And you can see it's just done one because I've had that selected. What we need to do is make sure we don't have any layers selected or any points. We're just going to click this little clear selection icon to remove it, so it's now blank, 0 selected. We redo this again. And it will calculate for all of the records in our data set the raster value calculation. So you can see that the code block there could do so much more. You could do multiple fields, multiple calculations in order to calculate your value. So there we go. We've got elevation. To delete raster value, right click on the title and delete field. Yes, we do. And away it goes. So it's a bit of a convoluted way of renaming a field there. So we've already checked Simpson Cross to see if it worked well. But what we're going to do is just look at an example of what the elevations were for a name of a place. So I'm going to use an example of Woodhead, which is what's in the worksheet. And I'm just going to use a tool within the attribute table called select by attributes. What that will do is select records which meet the particular criteria of an attribute that I'm interested in. And we do this by clicking the drop down and going select by attributes. It's just a way of querying the data to allow us to find things that we're most interested in. Now it looks fairly complicated, but we can do a lot just by clicking on particular things. The first thing that we want to do is we want to query the name. So we're going to go name equals, we could click get unique values, but there's going to be a lot of names in there. It would take a long time. So what we're going to do is just put a space in, a single speech mark, Woodhead, another single speech mark. That just delineates the search term that we're looking for. Click verify, and it says the expression was successfully verified. That means it's going to work. Click apply, and we can see that 13 records were selected. To see those 13 records, we're just going to click this little icon here which says show selected records. And here we go, we've got 13 places in the UK, data distribution that meet the criteria of the name Woodhead. So it shows that name's not a great unique identifier. If we want to see which one we're talking about, we can select a particular one, like this one, and it's highlighted in yellow. So it's actually a very powerful tool for just isolating certain features by utilizing the search by attributes, or select by attribute function. So what if we only wanted to show a visualization on the map that was only places with the name of Woodhead? What we would do is we could export this data and create a new shapefile, but that's just adding another procedure in that we might not want to do. What we can do is utilize an approach called a definition query. So I'm just going to close down my attribute table, and I'm just going to deselect my features by using the icon here. So it's just the blue icons have gone, so I've not got any features selected. I'm going to create a definition query by right clicking on the name of the feature that you wish to work on and clicking properties. It automatically opened into definition query, which is just a blank field for me here, but we can utilize the query builder. I'm going to add in name equals space single speech mark Woodhead speech mark. Click verify. It works. Click OK. And then I'm just going to click OK again to just finish the layer properties dialog. So you see now that we only see the points that meet the Woodhead criteria. So if you want to go back, or you want to change it, right click on the layer name, properties, and then just delete that query. From there, all your points come back. So definition query is a really powerful tool for visualizing certain elements of your dataset. Now we can use definition query to select multiple datasets and multiple fields. For example, we can build something a little bit more complex. So we could go type equals, and we maybe want a village or a town. So we click get unique values for this, which is a very good way of looking at categorical data. So if we go village, we've got several villages. We've got a capital village. So we go or type equals capital village, and then we go and elevation greater than 400. So let's click verify. Okay, so the expression was successfully verified. Click OK, and OK again. So we've selected quite a few villages here which were over 400 meters. However, there's quite a lot of records. Let's have a look. 12,000 have been selected. If we just remove the capital village, click apply, we've got only a few villages here. So we would have to do the same like so in order to be able to select this particular attribute if we had capital villages in here. So quite a complex approach if you've got some inconsistencies in your naming conventions. You may have to have a more convoluted style like that. But these are villages which are over 400 meters in elevation around the UK based on our data set. And you can do the same for towns, for example, maybe low-lying towns to identify areas that might be at particular risk of flooding. So I just remove the definition query. So you can do very complex operations if you wish. Now, we have a layer which contains locations and it contains the elevations. But what if we want to know what the postcode zone was for each of the locations? To achieve this, between two vector layers, we will utilize what's known as a spatial join. So basically, we're going to join the postcode layer to the points layer for the postcode zones that the points fall inside. And the spatial join is functionally very simple to achieve. So we just right click on the places with elevation dataset and we go joins and relates and join. That brings up this layer which is joining data. You've got several options. The first one is, what do you want to join to this layer? We can select it from a table, which we might have an ID field we wish to join, but in this particular exercise we want to join based on a spatial location. Choose the layer you wish to join to this layer. We want UK postcodes, and it gives you some contextual information. So you are joining polygons to points. So each point will be given all the attributes of the polygon that it falls inside. That's what we want. And then we'll just create an output file in a location where we know where it is. And click OK. So spatial join is now going to give each point the attributes of a polygon that it falls inside. Because there's many points, it may take a short time to complete. Try not to disrupt the computer whilst you wait, otherwise you may force a non-responding error, and then you may have to restart that map. The new layer, once completed, will be automatically added into the map, and then we'll just have a quick look at the attribute table to see if there's any data in there. Turn off the old layer. Here's a new layer. Right click, attribute table. We go across. We see that we've now got data from the postcode layer. All the way down. We can see the postcodes for each individual point. We can just run a quick symbology just to check that it's worked for all of our points. Symbology, categories, unique values, and we use label, add our values. Click OK. And there you go, you can see the different postcode zones around the UK. So we can now reverse this spatial drawing and go the other way around. Say for example we want to know what the average elevation of all the places that falls within inside the postcode zone. So we're just going to do it the other way around this time. So we use UK postcodes, right click, join and relates, join data from another layer based on spatial location. We can do places elevations with postcode. Each polygon will begin with a summary of the numeric attributes of the points that fall inside it, and a count field showing how many points fall inside it. So if we want the average elevation, we click average, and we give it a new output field. UK postcodes and elevations count, and click save. Okay, this time we're just doing the drawing the other way around, and by doing this we'll hopefully have for each postcode zone an average elevation and a count of the number of points, places that fall inside that particular zone. This operation takes slightly longer than the previous one, but remember it's drawing in many thousands of points on top of one another. So the new layer has been added to our dataset, and we can now see the UK postcodes elevations counts. We right click, open attribute table, and scroll to the right. We see that we get an average elevation as well as a count. These other fields are relatively meaningless. We're mostly interested in count and average elevation. So we can do some simple visualizations again using the symbology tool to try and determine which postcode has the highest number of places based on our particular input dataset. So right click, properties, categories, or quantities even. We take a value, average elevation. We've got an automatic classification applied. Click OK. So we can see that some of the blue areas have got the highest in the UK, the highest elevations. We can also look at the number of places by using the count field. Find out the most numerous is this area here with the most records, and then the lowest around these tracts of places. So we can do spatial drawing to do quite complex queries of our data. So what if you want to know how big a postcode area is and the data is not already provided? Let's zoom in to the northeast. If you use the measure tool, we can very quickly query the size of a feature. So we could use this particular option measure feature. Okay, click that and then click one of the polygons, and then we get 100,000 hectares, 95,000 hectares, 307,000 hectares. So we get some estimates of the size just by randomly clicking on features. You can also measure distances by using measure a line, for example, between these points here, and quickly measure between the two. $8,000 meters, 11,000 meters. You can change the units of distance and area as you wish by using this option there. But yet again, what if you want to calculate the area of multiple polygons in an automated fashion? So we can use the attribute table to help us achieve this. So the first thing we're going to do is open the attribute table. We will then add a new field by using the drop down and add field. And we're going to call this area. We want a double type with a precision of 10 and a scale of 2. Because we're not too sure how big the numbers are going to be. Based on our initial query, they were quite large. So we'll click OK. We scroll over to the right, we see that our new field area has been produced. If you right click on the title of the column, you see an option of calculate geometry. And this is where we're going to use this tool. We're going to use this to calculate the area. Just click that. So it asks us if we wish to do it outside of an edit session. Yes, we do. And it gives us an option. What property do we want to calculate? Area, use the coordinate system, the unit, we change to hectares, and click OK. Yes, we wish to continue. And there we go. We've calculated an area within that. If we right click, start descending, the largest area is Inverness, which is to the north of Scotland. The smallest area is London, WC. So, quite useful, rapid queries that allow us to calculate various different things. So we've covered here spatial joins, definition queries, select by attributes, renaming and creating fields, as well as measuring features in an automated fashion. Thanks for listening.